Hello, ladies and gents. Today we're going over lesson 1.9, how to divide rational numbers. So to start off, we'll start with some definitions. So the definition of a complex fraction is a fraction where a complex fraction has a fraction in the numerator and or denominator. So for example, if I were to write something like 2/3 divided by 5/5, this would be a complex fraction, right? Because we have a fraction in our numerator and we have a fraction in our denominator. All right. The second definition is that of the multiplicative inverse. So a multiplicative inverse is the value you can multiply a number by to have a product of 1. So for example, we could multiply 2/3 by 3/2 to equal 1, or 3/2 is the multiplicative inverse of 2/3. We could also look at something like 5. Well, 5 times 1/5 is equal to 1, so 1/5 is the multiplicative inverse of 5. So now we want to list 5 numbers and their multiplicative inverses. And what can we see from these examples? I'll just let y'all think about that for about 1 minute, and then I'll write some down. All right, so if you thought of numbers like 1/3 times 3, that equals 1. Or 5/2 times 2/5, that also would be a multiplicative inverse. Finally, let's do one more. Let's do 1,000 times 1/1000. So that's equal to 1. Now, what do we see from these examples? Well, they're all the reciprocal, right? If we take our original value and we flip our numerator onto our denominator, then that's what we're going to get for our multiplicative inverse. So let's look at 5/2 and 2/5 here, right? So from 5/2, we have a 5 in the numerator and a 2 in the denominator. And if I change that to a 2 in the numerator and a 5 in the denominator, then I'd have my multiplicative inverse. So to find our multiplicative inverse, we want to flip what's in our numerator and our denominator. So how do we divide with fractions? So when we divide with fractions, we essentially flip the second fraction and use multiplication. Or as one of my students said, we use the keep, flip, change method. Or for short, KFC, like chicken. Yep, we're going to use the keep, flip, change method. So we're going to keep the first fraction, we're going to flip from divide to multiply, and we're going to change the last fraction. So let's look at 2/3 divided by 1/2. So we're going to keep this 2/3 value. We're going to flip this division to multiplication, and we're going to change this 1/5 to 5/1. All right, so 2/3 times 5/1 would, of course, be 5 times 2, which is equal to 10, over 3 times 1, which is equal to 3. So our answer would be 10/3. All right, so we want to simplify the complex fraction, 2/3 over 5/3. So whenever we're working with complex fractions, we could also rewrite this as 2/3 divided by 5/3. And we're going to use our KFC method here. So we're going to keep that 2/3. We're going to flip the 5/3 to 3/5. And we're going to change that division to multiplication. All right, so what can we see when we're multiplying here? Well, for starters, these 3's are going to cancel out, right? We're going to cross-cancel those, and these will both be equal to 1. And then we have 2 times 1 over 1 times 5, which would be equal to 2/5. So our answer for 2/3 over 5/3 would be 2/5. All right, so let's look at an example here, a word problem. So the water level of a lake fell by 1.5 inches during a 1 2/3 week-long dry spell. We want to simplify the complex fraction to find the average rate the water level changed every week. So I have 1 1/2 and 1 2/3. Now the first thing I want to do is convert these to mixed fractions. convert these to improper fractions. So we're going to use our half moon method here. So it would be 2 times 1, which would be 2, plus 1 is 3. So 3 halves, and 3 times 1 plus 2, which is 5/3. So now I have a 3 halves divided by a 5/3. Or we can rewrite this as 3 halves times, we're going to change our division to multiplication, 3/5, because we're going to flip that fraction. Because we kept our first fraction, flipped our second fraction, and changed our division to multiplication. All right, so what does this equal? Well, 3 times 3 is 9, and 2 times 5 is 10. So the rate of water fell by 9/10 of an inch per week. All right. That'll be the answer to ours there. All right, so now we want to look at these values here. So we're going to start by filling out this table. We want to find the reciprocal and the multiplicative inverse of each value. So what would the reciprocal of -1/2 be? It'd be -2/1, which is just equal to 2. -2. And we want to find the multiplicative inverse of -1/2. Well, the multiplicative inverse of -1/2 would be equal to -2. Because when we multiply -2 times -1/2, we would get a value of 1. All right, now let's find the reciprocal of 2 2/7. Well, first off, let's rewrite that. So 2 2/7 would be equal to 16/7. So that implies that our reciprocal is going to be 7/16. Or we can write the multiplicative inverse as 7/16. Now how about 3 and 3/54? Well, 3 and 3/54 would be equal to 115/54, which is equal to, which is reciprocal, I should say. It's not equal to. So the reciprocal of 115/54 is 54/115. And then also the multiplicative inverse would also be 54/115. And then lastly, we want to look at 1/112. Where the reciprocal of 1/112 would be 112/1, which is equal to 112. And then the multiplicative inverse of 1/112 would obviously be 112. All right. So now we got some practice problems here. So we want to find the quotient of 3/10 divided by 3.8. We want to find 4/5 divided by 6/8. And we want to find -7/17 divided by 13 divided by 34. So on that last one, we want to remember PEMDAS, and we want to do what's in parentheses first. And then also on A here, since we have a fraction and a decimal, we're going to want to convert to the same. So either we're going to want to have 2 fractions or we're going to want to have 2 decimals. Alrighty guys, good luck with those practice problems.